In this video, we're going to talk about polynomials and behavior. So first, we're investigating graphs of polynomial functions. So hopefully by the end of this video, you will be able to investigate graphs of polynomial functions and graph them, rough sketch. We're not looking for perfectness when we're talking about end behavior. We really want to know, we want you to know what the graph should look like, how many curves should it have, how are they ending up, down, stuff like that. So what we're going to start with is classifying them by its shape. So remember, if we have something linear, okay, linear is like a line. It looks like that. It has a degree of 1. Now quadratic, okay, remember that's our U shape or parabola. Okay, notice that both of my arrows are going up. They end in the same direction, and that's a degree of 2. Okay, if I look at cubic looks something like this. Notice that my ending arrows, one's going down, one's going up. Okay, and that's a 3rd degree. My quartic, okay, if I do a quartic, what that would look like would be something like this. Okay, so notice my arrows are ending up and it curves 1, 2, 3, but quartic is a 4th degree, so you do turns plus 1 and it gives you what the degree is. Okay, again, turns plus 1. So the quintic, if I start like this, there's 1 curve, 2 curves, 3 curves, 4 curves, and then it goes up because I do plus 1. Sorry, I kind of messed up on that last part, so let me fix that. Okay, and my arrows end in different directions and it's a 5th degree. So when it's odd, my arrows are going in, oops, turn the page on me. It keeps doing it. Okay, when it's odd, my arrows go in different directions. Okay, opposites when they're odd degrees. When it's an even degree, okay, like 4 and 2, my arrows end up going in the same direction. So that will help us. So on this next page, what we need to know is, we talked about even and odd degrees. So odd degrees, my arrows end in different directions. Even degrees, my arrows will end in the same direction. Now we need to talk about the leading coefficient. If my leading coefficient is positive, meaning A is greater than 0, okay, A is greater than 0, what my graph looks like is it starts going down, okay, so the arrow is going down here, and then it ends going up. Okay, so this is what an odd degree would look like, okay, if my leading coefficient is positive. Now, if we're talking about as x is approaching positive infinity, so positive infinity is going this way. So as x approaches positive infinity, what is happening to p of x? P of x is my function. Well, it's going up. If it's going up, it's going towards positive infinity. So right here, I'm going to put plus infinity, positive infinity. Now, as x approaches negative infinity, and remember negative infinity is going this way, p of x, my function, is going down, so it's approaching negative infinity. Okay, so now let's talk about even degrees on this one. So an even degree, but it also has a positive leading coefficient. That's why I have a plus sign right there. So remember, even degrees, the arrows go in the same direction. So if I'm talking about an even degree, the arrow's going up, this arrow's going up. Okay? So now if I'm talking about as x is approaching positive infinity, so positive infinity is this way, x is approaching it, my arrow is also going up towards positive infinity. Oh, I was going to draw an 8. My arrow is also going up towards positive infinity. So as x approaches positive infinity, p of x, my function, approaches positive infinity as well. Now, as my function approaches negative infinity, so negative infinity is going that way, my function, well, it's still going up, so it's approaching positive infinity. So the main thing to know is that an odd degree, my endings, my endpoints go in different directions. If it's a positive coefficient, it starts going down and it ends going up. If I have an even degree with a positive coefficient, they both go up in the same direction, positive way. Now, if my leading coefficient is negative or a is less than 0, meaning a negative number, any negative number, okay, that changes how my function looks. So if it's an odd degree, instead of going down first and then up, it's going to go up first. Okay, so it's going to go up first and then switch to going down. Okay, so it reflects. Remember, that negative in the front reflects how our graph looks. So it's going to change as x approaches positive infinity. Well, positive infinity is going this way, so plus infinity. Okay, now my function's going down, so it's approaching negative infinity. Whereas now when it's approaching negative infinity, right here, so negative infinity is going this way, my function's going up and it's approaching positive infinity. So it reflects what it looks like. Now, if my function is an even degree, but the leading coefficient is negative, again, even degrees, my endpoints go in the same direction. Well, if it's positive, it went up. That means if it's negative, it reflects and goes down. Okay, so as, and I didn't write it on this part, now that I noticed that. So as x approaching positive infinity, I look at my graph, well, it's approaching positive infinity going this way. My graph is going down, approaching, so p of x is approaching negative infinity. Okay, and if I look as x is approaching negative infinity, so negative infinity is going this way, p of x, it's going down, so it's also approaching negative infinity. So this is a very helpful tool to determine what your graph's going to look like. So on our next examples, we're going to be given a function. So I have the function f of x equals negative 4x cubed minus 3x squared plus 5x. Based on this, I should be able to identify the leading coefficient, the degree, and what the end behavior will be like. So let's see what we can do. So the leading coefficient, I look for it to be in standard form. So right now I have 3, 2, and an x. Awesome, standard form. Meaning my leading coefficient is the first term. So my leading coefficient is negative 4. Then my degree, the highest degree out of all of them, well, that's cubed, so my degree is a 3. Now, in behavior. So I have an odd degree, meaning my endpoints will be going in opposite directions. And since it's negative, okay, if I have a negative leading coefficient, that means it starts up. So my graph will look something like this, based on that. Okay, again, a leading coefficient, it's negative, so I start going up and then in going down. Odd degree means my endpoints go in different directions. So as x is approaching positive infinity, meaning going this way, my graph is going down, so it's approaching negative infinity. Okay, as x is approaching negative infinity, okay, now we're going this way, my graph's going up, approaching positive infinity. Okay, let's look at the next one. I have example 2. Again, I want to know the leading coefficient, LC, my degree, and my end behavior. So I have x to the 6th minus 7x to the 5th plus x cubed minus 2. So leading coefficient is the number or coefficient in front of the variable with the highest exponent. So my highest exponent is a 6, meaning my degree is a 6. Okay, that's an even number, so then I should know my graph is going in the same direction. My leading coefficient is the number in front. Well, there's not anything written there, but I know it's a 1. So my leading coefficient is 1, which is positive, okay, meaning that they're both going up since it's an even degree. So now I need to know my end behavior, but what will help is if I kind of graph it. So it's a 6 degree, meaning I should have 5 turns and both of them ending up. So let's see if I can draw this. So I go 1 turn, 2 turns, 3 turns, 4 turns, 5 turns. So that could be this function. Okay, it's probably not perfectly this function, but it's a rough sketch. So my end behavior. So how I write this is I say as x is approaching, so I draw a line, positive infinity. What is, and this didn't give me a function, so I'm going to call this h of x. It didn't give me that, but I'm going to call it h of x. So h of x approaches. So if we're going towards positive infinity, which is this way, positive infinity, my graph is going up, so it's approaching positive infinity itself. Now, I have to do the second part. As x approaches negative infinity, so that means it's going this way, negative infinity, what is h of x doing? So h of x is approaching, well, it's also going up, so it's approaching positive infinity as well. Okay, so let's see the next one. I have p of x equals 2x to the fifth plus 3x squared minus 4x minus 1. Okay, so looking at it, my leading coefficient is a positive 2. My degree is a 5. Now we need to talk about end behavior. So let's try to graph it. It's an odd degree, meaning my endpoints go in opposite directions. My leading coefficient is a positive 2. So when it's positive, it starts down and ends going up. So it should have 4 turns. So let's see. It starts going down. So there's 1, 2, 3. 1, 2, 3. Here we go. 4. There we go. So 1 turn, 2 turns, 3 turns, 4 turns. That makes it a fifth degree. They're going in opposite directions. So in behavior, EB. I got lazy with my writing. So let's say as x approaches positive infinity, what is happening to p of x? So let's see. Here's positive infinity this way. My end behavior right here, it's going up. So it's approaching positive infinity as well. The next part, as x approaches negative infinity, p of x, what is happening to that? So let's look over here. So here's negative infinity going this way. My function is going down, so it is approaching negative infinity. Okay, example 4. I have s of x equals a negative 3x squared plus x plus 1. My leading coefficient is a negative 3. My degree is a 2. So my degree tells me that they go in the same direction. My leading coefficient being negative tells me that they're both going down. So what my function will look like, and since it's a degree of 2, it's a parabola, looks like a U. It's going to look something like that. So my end behavior, as x approaches infinity, this is s of x approaches, and if it's going down, it's going towards negative infinity. And as x approaches negative infinity, meaning as it goes to the left, s of x, it's also going down, so it approaches negative infinity. Okay, now on this next one, we're given the graph and we want to know if it says identify whether the function graph is an odd or even degree, and if it's positive or negative leading coefficient. So let's talk about degrees. So the degree. Remember, even degrees go in the same direction, odd degrees go in 2 different directions. So in this example, my endpoints, one's going up, the other's going down. This means this is an odd degree, so odd. And then my leading coefficient, we want to know if it's positive or negative. Well, if it starts going up and ends going down, that means it's a negative leading coefficient, so it's negative. Okay, let's look. This is my last example. Example 2, again, I want to know if it's even or odd, and then positive or negative leading coefficient. So my degree. Well, if I notice in this picture, they're both going up. They're going in the same direction. It is an even degree. Now, my leading coefficient. My leading coefficient, if they're both going up, let's see, if they both go up, think. Ah, there it is. If they both go up, it's positive. Okay, and based on this, you should be able to just do a rough sketch. Again, we need to know odd degrees, different directions, even degrees the same. My leading coefficient is positive or negative. How does that affect the graph? And then again, we should be able to determine based on how many turns it has. Okay, if it turns 3 times, you add 1, that means it's a 4th degree. So if I look, this turns once right here, twice, 3 times, I add 1, this would end up being a 4th degree. Okay, if I look back on the previous one, this one turns 1, 2, 3, 4. I add 1, which would make it a 5th degree. Okay, so these are just a few tools we can use to identify or investigate polynomial functions and their end behavior.